Alright, okay, so differentiation by first principles. Now, I'm going to preface this in that this rarely comes up. Okay? So these questions do not often come up, but we need to go through this process just in case. Okay? So do not stress too greatly. Now, the thing with first principles, it's a very strong link to functions. Okay, so we've covered functions already, so this shouldn't be a big issue for you, she says. Fingers crossed. All right, so differentiation. So let's make this for GCSE. If you are differentiating a function, it means that you are looking at the gradient of the curve, or whatever. Okay, so you are looking at the gradient of it. I'm going to focus on one example to help us get through this. So I'm going to consider the graph y equals x squared. Okay? We know that that is a parabola. Yes. It goes through 0, 0. Okay. Now I'm going to look at that graph, and I'm going to imagine I was trying to find the gradient of it at this point P. So to find the gradient of a graph, we can draw a tangent to it. Yes, remember that. And so we would draw a tangent to it at this point, and we would find the rise over the run. Oh, yes? Okay? That's how we could find the gradient of it. Now, that's not very scientific or accurate, because obviously how we draw the tangent could vary from person to person. Whilst the tangent is supposed to only just touch at a certain point, it's very difficult to actually draw those lines. But let's focus in. So what I've done is I've taken this portion here and I've enlarged it. So this is my curve, this one here. And oh no, that's a line. This one here is my curve. And then that is my tangent, just touching. Yes? So this is my point P. So that's where my tangent is touching. I'm now going to also consider a point Q that's really close to P. Okay, but it's too close for me to put on this diagram. It's close enough that it's here on my my tangent. And that distance between those 2 points is just h. Okay, so these are my x values for the points. So point P, what have I said? So this is x, okay, normal coordinates. So for point P, it would be x. X, and I'm going to call this one fx. Yeah? Yeah, okay with that? So if this is my general point x, fx, so that would be here x, fx, then how would I describe the coordinates of point Q? How would I describe this part? This value here? If I know that this measurement here is h.
hx minus h.
Remember, h is multiplying x plus h. Yes? So Maddie, you gave her a clue there. Which means that this here would be f. Oh, I'm loving it. I am loving it. Lesbians, yeah? So, we can fill this in here. So Q is going to be x plus h, and then f of x plus h. And remember, what we're saying is that this h, this distance between them is really, 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 really tiny. Okay? It's just enabling us to find the gradient of the curve. Okay, so h is really, really small. Gradients, we know, are rise over run. Okay, so the difference in the y values over the difference in the x, rise over run. Okay, have we seen this triangle means change? You've seen that in science?
Yeah.
Okay, so the change in y over the change in x. And we're going to call that dy dx. Okay? Okay, we're just using a bit of poetic license. So dy dx. So the change in y, how would I find the change in y? Well, I've got this value, subtract this value, yes? So f of x plus h, subtract f of x. And that means that my change in x would be what? Good. X plus h minus x.
You would have to go back as well.
No, because they're just adding and subtracting. There's no multiplying going on. Okay. We can't do anything with the top here. It's just f of x plus h minus f of x. But look what happens on the bottom. It's just going to be h. Now this is the crux of differentiating by first principles. Okay? This is what we are considering when we are differentiating by first principles. And can you... Has anyone got their formula sheet with them? No. So yeah, this is given to you on your formula sheets. Okay, so you don't need to learn it. You just need to know that if you're having a question that talks about first principles, that you know you've got it there to refer to. Okay? Well, how are we going to use that? Right, so... okay, so m is prone to the gradient, yes? I don't know why I put that. Anyway. So f of x plus h. What happens when we've got x plus h in the bracket, and we know that our fx is x squared? Okay, you're talking transformations of graphs. You are totally correct in that, but how would I input that into my function? Yes, that's what I'm trying to say. So if I had said find f3, what would you do? You would substitute 3 into here, yes? But we're finding f of x plus h. So you're going to say that that's x plus h squared, yes? Awesome. Maddie, you're on fire today. I'm loving it. And then subtract fx. So I'm going to subtract x squared, also, over h. Right, we need to do some simplifying. Okay, I can see I've got x plus h all squared. So how are we going to expand that? FOIL? Yeah. Or, if you're really fancy pants, if you remember your binomial expansion, just say it. Okay, obviously no one does. So if we were to expand it with FOIL, we'd have x squared plus 2 lots of xh plus h squared. I know that because it's a perfect square, and I just remember that. Okay, so I've got x squared plus 2xh plus h squared. Now, you don't have to learn that. Okay, you would be able to FOIL it and get that answer. Oh, well, I want 2 equals, so I don't know why I put 1 there. Sorry. I look at the answer here, which I pretty much do. I think it's stupid. Right, so now we need to do some simplifying. Okay, so obviously on the top I've got an x squared, subtract x squared, so that's a Von-Berger. Now I can see I've got some h's going on both top and bottom. Remember the rules of simplifying is it has to be multiplied, so you need to factorize the top in order to cross stuff out. Okay, so I'm going to factorize this top first. So the only thing that's common is just one of the h's, and I've got 2x plus h. Yes? Now, when I say it has to be factorized, obviously, if you make sure that you cancel one h from both of the terms on the top, you don't officially have to factorize it first, but it's always easier and safer to make sure that you do, to make sure you're not forgetting to cancel from one of the terms. Alright, but now we can see that we've got h top and bottom, so that could also be cancelled. Now, as a tip for you, when we are doing differentiation by first principles, you will find that this first term and this last term, 99% cancel each other out. Okay, so you will generally be getting rid of this thing at the end. Okay, you will also 99% of the time, I think I want to say 100% of the time, get rid of the h on the bottom somehow. Okay, so this process becomes very familiar to you, or will become very familiar to you. So obviously we're just left with 2x plus h. But what did we say? We said that the value of h is really, really small. Okay, so if we're trying to find the gradient of this, and we're saying that h is really, really small, is that value of h going to have any effect on the gradient? No. Okay, so what we can say is that this bit here is just fancy. So we're saying that the limit as h approaches 0, so the limit as h gets really, really close to 0, in other words, it's so tiny, then 2x plus h would be equivalent to just 2x. Okay, so that's what this fancy bit here means. So as h approaches 0, so in other words, as we consider h getting smaller and smaller and smaller and smaller, then this 2x plus h just becomes 2x. Now that means that the derivative of x squared would be 2x. You may or may not have remembered that. Okay? We're going to look at rules of differentiating in the next little section. So it's a bit of a chicken and egg situation. Sometimes I prefer to do that first to remind you about the rules of differentiation. But this is a good recap of functions. Okay, that wasn't too bad, was it? So what I'm saying is that the derivative of x squared is 2x. Okay? Now, you are going to do enough questions that you would have been able to tell me that without doing any of this lava. Okay? The difference is that if they specifically ask you to use first principles, you must show all of this expansion and cancelling and the final step of getting rid of h. Okay? So that's the difference between a question on first principles and a question just normal differentiating. They won't give you a very complicated question using first principles. It will be a basic one. So you will know whether you're what you should be ending up with. Okay, so you will know what the answer should be because you're going to have those skills of differentiating. It's making sure that you can manipulate all of your algebra to make sure you get that. So f dash x is f of x plus h. Subtract f of x over. And as I said, that's given to you in your formula books. Okay. So let's do a couple more examples. I think I've got 3 or 4. Probably excessive number of examples, but it's probably better too many than too few. See if we can get them all done this lesson. Alright, so x cubed. Same thing. What do we say? And then what did we do?
Expand the bracket.
Expand the bracket. Okay? And as your power gets bigger and bigger, you're more it's more beneficial to try and remember your binomial expansion rules. Does anyone remember what is a binomial expansion?
1, 3, 3, 1.
Okay, so we're going to be using this line.
6, 4, 1.
Yeah, 1, 4, 6, 4, 1. Yeah, that will be the next one. But remember, for this power of 3, we're going to want this one. Yes. So our first term is going to be x cubed. Yes. And that was the 1x cubed plus 3x squared, and then h is going to come into play. Yes, remembering this now? So we start with the x as the highest power, and the x is going down a power, while the h starts increasing in the power.
The first 1 is 0.
No, so the first 1 is a secret one here.
At the top of the pyramid.
Yes. And then this is going to be plus 3x squared plus h cubed. So binomial expansion really does help when it comes to stuff like this, even for your powers of 3. She says. Hopefully you will agree. So that's my expanded brackets. Subtract x cubed over h. Whoops. And then we can start cancelling stuff out. So obviously our first term, those, and then we want to factorize. So h bracket 3x squared plus 3x h plus h squared. Then we cancel out our h's. And then this is where we write that weird thing. So we say lim as h approaches 0. This is going to be 3x squared plus 3x times 0 plus 0 squared.
So, it's always going to be like something to be followed on.
Yes. Now, well, let's chat about rules of differentiating. Does anyone remember how it works? So if we've got x cubed, do you know how to differentiate something? This power comes to the front, you multiply, and then you just take 1 off the power. So that's why this 3 has now become in front, and then this has gone to be the power of 2.
Oh, so it goes like after x. And then it equals x cubed. It'll be 4x to the power 2. I mean, yeah.
No, you said x cubed.
I know cubed is to the power 4.
Then it would be 4x cubed, yeah. Okay, so
And now the f dash x, I'll be after that.
and that's what I mean. So we know the rules of differentiating means that our answer is going to be 3x squared. Okay? So I knew that I was going to end up with this. But I just had to show this working. So I had to make sure I showed my proper expansion. I showed my factorizing to get rid of my h on the bottom. Substitute to do my 0. And I was left with that. So if at any part you don't end up with what you expect, something's gone wrong. Okay? So that's where you just need to go. And it will just be an algebra issue. It won't be you don't know how to differentiate. You know, you will be able to do it. They will be straightforward derivatives. It's just whether you can show that using first principles. Okay? So, next one. I don't think I've written anything else down. Okay, so x4. Same thing. Okay? So, x plus h to the power 4 minus x to the power 4 over h. Okay, so we need to go back to our Pascal triangle. So we had 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. What was the next one?
1, 4, 6, 4, 1.
Okay. So this is good recap of binomial expansion. So our first term is going to be x to the power 4. And then what will it be?
X power 3.
Careful, don't forget your Pascal's number.
Oh, 4.
So 4, x to the power 3, yeah?
H.
Yeah. Plus
6.
6,
X to the power 3.
yeah?
Plus H to the power
Not plus, x.
I mean, H to the power 3.
Yeah. Plus
2. X to the power
1, yeah.
H to the power 3.
Yeah.
F.
Secretly h.
Oh, yeah, H. To the power 2.
Yeah. Okay, so that's my expansion. Don't forget the minus x to the power 4. And let's be honest, if you were to look at that, you'd probably be like, oh, what on earth? This is ridiculous. This is so hard. OMG. But you know your answer is going to be 4x cubed. Okay, so you know that's what you're going to end up with. Your power comes in front and you take away 1 from the power. We'll take away 1 is 3.
No, I do it. Yeah, that's right.
You took away first and then multiply.
No, when you said cubed, I thought squared.
Okay, interesting.
Yeah.
Interesting. So it went a little different. I really have to stop being quiet since I Alright.
So, but when we put that in bracket and stuff.
Yeah, 2. Because the only thing, the only thing that's common to all of these 3 is just one of the h's.
Yeah.
Yeah, because this one's only got an h. So you can't bring any more h's out than just one of them. Okay? So your h is going to come to the front, and you've got 4x cubed plus 6x squared h plus 4x h squared plus h cubed. And it still looks crazy complicated because we can only cancel them out. And so you think, well, that's not what I want. That's way too much. But
That's even near 0.
yes, and that's where this comes in because this one you've got to multiply it by h. This one you multiply by h squared, and that's an h cubed. And when h we're pretending that's 0, obviously all of these 3 things go, and we're just left with this one that we wanted.
Wait, say that one more time?
So because each of these 3 terms have an h multiplied by them, it means that because we're now saying the limit as h approaches 0, it means that we're replacing this with a 0.
Oh,
And so that means that each one of those is 0 and disappears.
Maybe I could get.
And it's funny because this is you talk to people and often they're like, oh, that's difficult, that's really hard.
I think once you just get these steps on, it's just like, why alright?
But that's with any maths though, isn't it? That's not like
Not all
if you
math.
follow the process. If you follow the process,
See what? Remember the other day I was telling you when some just like this makes sense. Like I can see why you're doing what you do. The other stuff is like you're doing it because you want to.
I know, but also the tricky thing is that, and I get it, I completely understand. Like I do this often, and that's why that's why I know what I'm doing because I'm doing it so frequently. You do it this one lesson, and then you go off and learn something else, and then you go off to learn something else, and learn something else, and then you go play netball, then you go to the gym, you show off your abs, you drink a little, that's what happens. All that. So that I understand. The thing is, and also this all makes sense while I'm going through it with you. When I tell you in 4 weeks' time to go and do a question like this, you're going to be like,
Exactly.
But it's because you haven't had that practice. But this is where the difference comes in, and sometimes people are like, oh, this is smart, they get it, they can do it. It's perhaps because they've gone away from the lesson and maybe try to question at home that night to make sure they remember what they're doing. You remember things because you practice doing them. And so if you want to get better at that, it means you have to take some time in your own time and answer the question.
That's hard.
I know.
Time.
I hear you. I totally hear you.
And
And
it was 48 hours a day.
I know. I hear you, sister. Right, okay, let's get this bad boy. So this should be a lot quicker because it's just x. So, but the principle's still there, so we've got x plus h. Take away x over h.
You're not just looking at x.
So x, take away x cancels, and we're left with h over h. What's that? What's the derivative of this? Okay, so f dash x, for this case, is 1. And if you remember anything about derivatives, when you have just an x here, the derivative of it will be the coefficient of it, and there's a secret one in front of it. So if this had said 3x, the derivative would be 3. If this had said 17x, it would be 17. Okay, but there's a secret one here. So I'll do it. Okay? So that was a nice one. You get that. No expansions necessary. Okay, so this is getting a bit more complicated. So we've got 5x all squared. So we've got 5 lots of x plus h all squared. Take away 5x squared. So this is where you've got to be careful when you've got to follow their maths. Okay? So we need to make sure that we're expanding just our bracket. Our 5 is nothing to do with it just yet. Okay? So we've got a normal FOIL expansion, but now we've remembered our binomial expansion rules. We know this is x squared plus 2xh plus h squared. And so I would always advise try not to skip steps, because with these things, that's where mistakes can happen, and I don't want you to mess up. So then we're going to expand our 5, so this is going to be 5x squared plus 10xh plus 5h squared. And then some 5x plus 5x squared, and 5x squared goes.
It'll be now more. I see.
Yeah.
But
H comes out.
what is it?
Yeah. Where?
Like when you factorize
Oh, could I react? Yes, I could secretly. However, totally correct. However, I only want to get rid of my h. So, whilst 5 is common, yes, yeah, that's a good point. You only want to bring out the h so you can cancel that out. So if you bought the 5, you don't have to expand it yet. So just bring out the h. Good point. Thanks. So our derivative is 10x. I'm auditioning for your bar.
That's what she just said.
Alright, so this one is a little bit more complicated. So I'm going to start over here with this bad boy. So we've got 3 lots of x plus h squared plus 4 lots of x plus h. Okay? Because remember, when we have functions, we have to replace every x with our thing that's in the brackets. So that's 3x squared plus 4 lots of x plus h. Take away all of this. Now, I have had to put this in a bracket because there's more than one thing.
Yeah.
Okay, so up until this point we've only had the one term, so I haven't needed to worry about it. But here I do need a bracket around it because I'm subtracting both. And that again is something that some of you are not so hot at. And that's unfortunately where some and they're those careless mistakes, that they're the frustrating ones that cause results to be affected. And if it happens too early on, the mark schemes don't allow any other marks to be awarded.
Yeah.
So it's the ones you don't want to mess up. Alright, so here we've got 3 lots of x squared plus 2xh plus h squared plus 4x plus 4h minus 3x squared minus 4x. I'm rushing this, we're going at the end of the lesson.
It's on the confused stuff. Yes, section 2.
Whoops. Alright. So here we can start cancelling stuff out. I know, hopefully, as I say, I'm sorry, I checked quickly because I'm not seeing this. It's not past these days. It's just now 9.45. So the 3x squared's gone, but it's buried in here somewhere. I've also got a 4x, so that can go as well.
Jeez Louise.
And bringing out my h, because remember that's what I want to bring out. Okay, so just be careful you don't lose any constants, assuming that it's just the first term. So this one, the 4 still is in there. There's only that middle term there, the pH still. And the words at the bottom, they're just terminology for you. So if you hear things, any of those, that's what it's connected to differentiation. Okay? That's what it is. Well done, everybody. Thanks.
No, let me look at this.